This is the beginning of Pascal's triangle, which we are going to use for binomial expansion. Now the way this is put together is we have the rows corresponding across here, and we have 1 as our coefficient on the outside, and then you can see that the coefficients above give us our next term. And so as this expands, we end up with our triangle like this, and this is the first 10 rows of Pascal's triangle. Now what we want to pay attention to is, as we are looking at the expansion of this, these exponents over here correspond to the rows. So what we end up with as we go through and do this is we're going to have Pascal's triangle. Like I said, it starts with 1 on the outside, so we have our triangle put together here. And it continues on, and as we're looking at this, we want to pay attention to this. We're going to consider as row 0. And then here we have row 1, and here is row 2. All the way down the line, this is 3, this is 4, this is 5, and you can also notice that these first terms across here, 2 comes here, here's 3, here is 4, here is 5, as we work our way down. Where we will use that is if we're expanding a binomial like this, where we have our quantity of x plus y and we're raising it to the 4th power. Now what this means is we have x plus 4 times itself 4 times. Now rather than foiling this out, because we're going to get more complicated problems than this, what we can use is we can use Pascal's triangle to help us with this. So here we have an exponent of 4, so I'm looking at row 4, and this is telling me my coefficients for each of these terms. Now the other thing I know that's going to happen is I'm going to end up with an x to the 4th with my first term, and as I FOIL this out, I'm going to end up with a y to the 4th in my last term. Now my x's are going to count down while my y's are counting up. Basically what I have here is x times y to the 0, and I have x cubed times y to the 1st, and we're going to have x squared times y squared, and then we're going to have x to the 1st times y cubed, and then I have my last term. Now where these numbers come in across Pascal's triangle is that's my leading coefficient. Here's the 4, here's the 6, here's our other 4, and then there's the 1 there. So we've now written this out to where our expanded notation is going to be 1 times x to the 4th, and then here we have 4x cubed y to the 1st, and then here we're going to have 6x squared y squared and 4x y cubed, and then we have 1 y to the 4th, and that would be our expanded form. Another example, here we have 2x plus 3y. Here's our binomial, and we're going to cube this. So again, for my first part, I know that I'm going to have 2x cubed times 3y to the 0 power as my first part of this, and then our first term is counting down. That's going to be 2x squared, and then my second term is counting up. That's going to be 3y to the 1st, and we continue that. 2x is counting down, that's to the 1st power. Second term, 3y, is counting up. Now that would be squared, and we have 2x to the 0 power and 3y cubed. Now again, as far as these leading coefficients that go along with this, that's where we look to Pascal's triangle. Here we have our exponent is cubed, so we're going to look at Pascal's triangle, and I'm going to go to row 3, and I can see my coefficients going across here. I have a 1, 3, 3, 1, and so when I go back down here to my problem, it's a 1, 3, 3, 1. When we look at the 4 separate pieces of this, here's my first term, second term, third term, fourth term, and now we would just simplify from there. So we have 2x cubed. 2 cubed is 8, and then x cubed, and anything to the 0 power is equal to 1. I have 1 times this, so that's my first term is 8x cubed. And then here we have 2x squared. The 2 squared is 4, x squared is x squared, and then we have a 3y. I do have my 3 to begin with here, so I have 3 times 4 is 12, times 3 gives us 36. I have an x squared and a y. My third term, I have 2x. Now I have 3y squared, so that's going to be a 9y squared. And then we have 3 times 2 times 9 for our coefficient. That is 54. I had an x to the first and a y squared. And then in our last term, again, anything to the 0 power is equal to 1. We have 3 cubed is 27 times 1 is our leading coefficient. So we have 27y cubed. So that is using Pascal's triangle along with the binomial theorem. Binomial theorem, as far as expanding these, now notice here it's just variables. I have n as my exponent. So we're saying that the first term is going to be my first term to the nth power. And then my next term is going to be whatever my exponent is. That would be my leading coefficient. And now my first term is counting down, so that's going to be an n minus 1 for my exponent there. And my second term is now counting up. Now here was basically y to the 0 power. So now here we're going to say it's y to the first power. And so as we continue on through this, we're going to have our leading coefficients here coming from Pascal's triangle. And then we have our exponents counting down for the first term and up for the second term. And so we would end with, as I continue on, my next to last term is going to again have my n as my leading coefficient, because if we look at Pascal's triangle, here in row 7, I had 7 as my second term and as my next to last term. So I have that n value times, and now we have our x value to the first power and our y value then to the n minus 1, so they've counted up. And then our last one, we have 1 for that leading coefficient times y to the n power. Now, other than Pascal's triangle, there is another way to find these leading coefficients across here, and that is using a combination. So we can use, remember, for a combination, we're going to have our first term here, so we're saying is nc to the r. Now our n value is coming from our exponent here. The r is coming from which term we're working our way across. So when I think of this as my term, that comes from up here, and so we're going to say, as we work our ways across, this is term 0, this would be term 1, this is term 2, just for the sake of our combination when we're doing that. So for example, if we have our combination of 8 choose 2. Now the way that we can also think of this is our n factorial divided by r factorial times n minus r factorial. Now of course we have our calculators that can work this out for us too, but when we go 8 choose 2, we have our 8 factorial on top. Remember, that's 8 times 7 times 6 all the way down to 1. And then we have our r factorial, here's that, 2 factorial, and then this one is n minus r. So in this case that's 8 minus 2, so that would be a 6 factorial. Now, as we're looking at this, we do have some stuff that's going to cancel out, because I can think of this as 8 times 7 times, there's 6 factorial right there. So those are going to cancel each other out. So what I'm left with is 8 times 7 on the top, and then 2 times 1 on the bottom. So that ends up being 56 divided by 2, that's 28. So that is another way that we can find, that would then be our leading coefficient. If I was taking something to the 8th power and I wanted to find that second term within there, then that's how I could find that using a combination. And the last thing to mention here is if we're doing differences instead of the sums, then we will alternate signs throughout. So here we have x minus 2 that is cubed. So again, my x's are counting down. I have x cubed, x squared, x, and then here's x to the 0. And then my leading coefficients are coming from Pascal's triangle. So because this is a 3, it's going to go 1, then here's 3, and then I have the 1 as my leading coefficient here from Pascal's triangle. And then the second part of this, where we're getting these coefficients, is from my second term. Remember, here we have our second term to the 0 power. Here is 2 to the first. Here is 2 to the second. Here is 2 to the third. So I'm taking that coefficient. 3 times 2 is 6. 3 times 4 is 12. And then here is 1 times 2 cubed, so that is 8. And again, we're alternating signs because we were taking the difference here. So this one's positive. Then we subtract. Then we add. Then we subtract. Here I have y minus 3 to the 4th. So again, my y's are counting down. And then I have my second term is 3. That part is counting up. So here's 3 to the first. Here's 3 to the second. 3 to the third. 3 to the fourth. And then as far as my leading coefficients, again, this is coming from Pascal's triangle. Because we're looking at 4, then I'm looking at row 4, in which case I have 1, 4, 6, 4, 1. So that's where I have the 1, 4, 6, 4, and then there's a 1 here. And so we have 4 times 3 to the first gives us our coefficient for that term. 6 times 3 squared gives us 54. 4 times 3 cubed gives us 108. 1 times 3 to the fourth gives us 81. And because we were taking the difference here, we alternate signs throughout. So we're positive here, then it's minus, plus, minus, plus.